Hi guys, today we're gonna talk about one of the most controversial subjects, how to draw a hydrocarbon structure. Solution is so easy, just come from the end of structure to the beginning. Don't you believe it?
No, I don't.
So let's check out 1, 2, 3 example to prove it that it is possible. Let's see that. In the first example, when we come from the end to the beginning, the first word that we see is heptane, and we know that we write the main chain in the last, so heptane is the name of our main chain. But we have different kind of hydrocarbon, for example alkane, alkene and alkyne. So it is which one of them? As we remember from the video that we talked about have to name alkene and alkyne, we understood that when our main chain finish with A and E, it is alkane, and when in the end of our main chain is E and E, it is alkene, and when it finishes with Y and E, it is alkyne. So in here, heptane finishes with A and E, so it is alkane, and we know in the alkene all of the bonds are single. So we will draw 7 carbon and number it from any way that we like. For example, I number it from this way. Then when we go, we see methyl, and we know methyl is 1 carbon as a substituent group. But where have to we put it in our main chain? To which one of the carbons? Before methyl, we see 4. The 4 is number of the carbon in our main chain that we have to attach carbon to that. So we stick methyl to carbon number 4 in our main chain. And in the end, we see chloro that we have to attach it to carbon number 2 as we see it in our example. So we draw first example so easy. Let's draw the second example. As we know from our notes, again we come from the end to the beginning. The last word that we see in here is actine, and we know actine has 8 carbon, and the kind of our hydrocarbon is alkene, because the end of actine we see E and E. So it is alkene, and we know in the alkene we have double bond. So we draw 8 carbon and number it from, for example, this way. But where have to we put the double bond? As we remember, in alkene and alkyne, we have to write the number of the first carbon that attached to double bond before our main chain. And we see before actine number 2. That means we have to draw the double bond after that second carbon, after carbon number 2. Then we see 3 methyl. As we know, when we have more than one same substituent group, we use di-3-tetra for the number of same substituent group. For example, di for 2, 3 for 3, and the others. In here we see 3, so we have 3 methyl. That we see before methyl the number of carbon in our main chain which we have to put the methyls. We see 4, 5, 5. So we have to stick the methyls, the 3 methyls, one of them to carbon number 4 and most of them to carbon number 5, as we see in the example. Then we see ethyl that is sticks to carbon number 3. In the end, we see bromo that is attached to carbon number 7. So this example is done too. Our last example. In here we see a hexane. So we have to draw 6 carbon. But at the end of hexane we see Y and E. So it is alkyne, and we have to face a triple bond in here. But before hexane we see cyclo. So it is a cycle structure, and we have to stick the end of our structure to the beginning, and it will become like this. As it is cycle, we could put the triple bond in anywhere that we like. For example, I put it in here and we number it from the triple bond. Then we see a methyl that it sticks to carbon number 3, and then we see bromo that it sticks to carbon number 4. It was all of methods that you have to know about drawing a structure with your best. Good luck.